In 430 BC, an ancient Greek philosopher named Democritus was the first person to come up with the idea of an atom. His theory stated that substances made up of tiny, indestructible, indivisible particles are called atoms. He came up with this idea when he walked on the sand and thought of how the sand used to be made of pebbles. These pebbles would have broken apart to form the sand. He thought that the sand would eventually break down into smaller particles until it couldn't break any further. Then the smallest indivisible particle that would be left was the atom. There are two main parts to his theory. First, that atoms are indivisible, and second, that they are also indestructible. His idea lacked experimental evidence and was only based on reason. During the same time Democritus lived, there was another scientist who had an idea of what matter was made of, named Aristotle. He did not believe that matter was made up of tiny particles called atoms. Instead, he believed that matter was made up of 5 basic elements. These elements included earth, water, air, fire, and ether. Even though his idea was incorrect, it was more accepted than Democritus' idea for about 2,000 years. Aristotle and Democritus both lived before the development of the scientific method, and this meant that their ideas lacked experimental evidence. In 1778, Antoine Lavoisier proposed the combustion theory, which was based on sound mass measurements. He named the gas and oxygen elements and also proposed the law of conservation of mass. This law stated that matter cannot be created or destroyed, only rearranged. In the early 1800s, a man named John Dalton developed the first atomic theory. This theory was based on his experimental evidence and observations and has 4 main parts to it. His theory states that all of matter is made up of tiny, indivisible atoms. All atoms of a given element are alike, but are different from the atoms of any other element. Compounds are formed by the combination of 2 or more kinds of atoms. And number 4 states that chemical reactions occur when atoms are rearranged. John Dalton pictured that atoms were solid spheres, and his idea that atoms are indivisible was true for almost 100 years until the work of J.J. Thomson. In the late 1800s, a man named J.J. Thomson discovered that atoms could be divided, and he also discovered a negatively charged part of the atom called the electron. He worked with the cathode ray tube, which was a sealed glass container. This tube had 2 electrodes separated by a vacuum, and when the particles struck the other end of the tube, a glowing patch was created, visualizing where the particles were. He discovered if you use a magnet, it could be used to bend the ray. A negative magnet would push the ray away, creating the negatively charged particles, and a positive magnet would attract the positive charged particles. Thomson revised the atomic theory to include these particles and called his theory the plum pudding model. The next discovery was founded by Ernest Rutherford in 1911. He discovered the positively charged particle of the atom was called the proton. He discovered this by using high-powered alpha particles beaming at a thin sheet of gold foil. Since the alpha particles were massive in size and were traveling at high speeds, he expected that the particles would pass right through the gold foil. This hypothesis was based on J.J. Thomson's plum pudding model, which he predicted that the electrons were distributed throughout the atom and the rest of the atom would be positively charged. Because of this, they didn't think that there would be much interference for the alpha particles and believed that they would pass right through the atom and would be detected on a screen on the other side. To his surprise, he found that some of the particles scattered and some of them deflected backwards. This meant that J.J. Thomson's model of the atom had to be adjusted to fix the new evidence. He believed that there must be a massive particle located in the center of the atom and that it must be positively charged, and he believed that electrons were circling around the outside of this central particle. This meant that the atom was made up of mostly empty space. The next discovery took place between 1908 and 1917 when a man named Robert Millikan and one of his graduate students named Harvey Fletcher attempted to measure the charge of an electron. Earlier experiments by J.J. Thomson showed that atoms contained some type of negatively charged particle, but it was still unknown. With performing their oil drop experiment, they discovered the charge of electrons as negative. The next discovery took place in 1924 by a man named Louis de Broglie. He proposed that waves can act like particles and particles can act like waves. He suggested that electrons are better described as waves rather than as particles. This was important because now we can describe the energy of electrons better by looking at its wavelength rather than just its mass and velocity. The final scientist that took part of the atomic theory was James Chadwick. In 1932, he discovered the neutron. Because of him, we know that neutrons are located in the nucleus of the atom along with the protons.